All right, so your warm up, your breaking point is at 6, so that's here. And then if you look, your closed circle is going to be in your top function. So this is closed. And we have a closed circle at 6. So when x is 6, let's see, negative 2 times 6 is negative 12, plus 5 is negative 7. Okay, and you can use your calculator to aid you. So at negative 6, we're at negative 7. Okay, and this is saying for x is less than or equal to 6. So it's anything less than 6. So I'm just going to pick some values that are less than 6. So let's say like 3 and 0. So when x is 3, again, you can either use your calculator or you can, substitute in values. If x is 3, you're at negative 6 plus 5, which is negative 1. And if x is 0, you're at 5. So we are at negative 3, 1, 2, 3, negative 1, and 0, 5. So your graph on that part will look like that. Okay, and remember, you cannot have one graph be on both sides of your breaking point. So that breaking line, that 6 value, we can't have it be on both sides. So now this is going to be our open circle because we're not including 6, but remember you start there anyway. So if x is 6 for x minus 5, again, you can put it in your y equals and look at your table, but 6 minus 5 is 1. So at 6, we're at 1, and that's going to be an open circle. And then we want everything greater than 6, so I'm just going to do a couple values, maybe 7 and 8. Okay, I know these are both going to be straight lines. They're both linear. So when x is 7, y is 2, and when x is 8, y is 3. So at 7, we're at 2, at 8, we're at 3, and then we would continue on that way. Okay, so now what we're going to do from here is talk about domain and range. So if you look at this, remember domain is all of your x values and range is all of your y values. So if you're going from left to right, so our domain, I'm traveling along my x line, okay? This red graph would continue forever. I'm just not going to graph it that way, but right, we would continue forever. So there would be a line no matter what x value you're at. And then same thing with the blue. Now the thing you want to pay attention to is the fact that you have this open circle here. But at that x value of 6, you might have the open circle up on the second function, but down here you have a closed circle, so it's accounted for. So your domain here is going to be negative infinity to infinity, because between the two functions, every single x value has a point at it somewhere. Okay. Now for your range, this is a little different, because if you look at your range, that's bottom to top. Well, there's no graph happening below this point on the red graph. And if we keep going up, there's a point happening over here. Again, there's an open circle, but it's covered over on the red line. So there's definitely a y value no matter what going up. So it's just starting at a y value of negative 7. So your smallest y value with a bracket, because it's a point, is negative 7, and it goes to infinity. Okay, so domain, you just need to check and see. You can almost think, okay, if I were to draw vertical lines here, would I hit a graph at every single point? You do, so it's negative infinity to infinity. For your range, if you were to draw horizontal lines and check every y value, you would hit a graph at least at every y value until you got to negative 7 and below, but then we don't have anything. Okay, so let's actually go back, and I want you to get out your notes from Friday. And we are going to go through domain and range with those. Okay, remember I said we left them blank and we would come back to them. So if we look at domain and range for number 4 on the notes from Friday. All right, so domain, that's left to right. So do we have, for every x value, do we have a graph? So again, the blue line's covering everything. we have this open circle on the green, but the blue circle, filled in circle is above it. So your domain is negative infinity to infinity. Every x value, at every x value going left to right, there's some sort of graph, okay? Now for your range, you want to think, okay, if I were to check all of my y values from bottom to top, well, there's no graph down here at all. The graph doesn't start until a y value of 1. And at that point, the smallest y value we're getting here, remember the yellow line is just your breaking point. It's not part of your graph. The smallest y value we're getting here is 1, and it's an open circle. So that needs a parenthesis. And then those y values, as you go up, will continue on forever. If you look at that green line, that would get bigger and bigger and bigger and bigger. So it's 1 to infinity. Okay. All right, for number 5, our domain, again, left to right. The pink is covering everything over here. We have an open circle on the orange, but a closed circle on the pink, so that covers the x equals 0 line. And then it continues on forever. So there, no matter left to right, there's always some sort of a graph. So every x value is accounted for, negative infinity to infinity. And then when we talk about range, going from bottom to top, well, this pink value is going to continue on down. So every negative y value will be covered with that. And the orange value is going, or the orange graph is going to continue on up. So every graph will be, I'm sorry, every y value will be covered with that. So that's negative infinity to infinity. Okay, so for number 6, our domain. Okay, so this red graph looks pretty skinny, but still, if we were to continue on forever, it is going to go all the way left, and the purple will go all the way right. Your open circle is covered, that what x value is covered with a closed circle above it, so your domain is negative infinity to infinity. And your range, well, the smallest y value we're getting, there's nothing going on down here. So the smallest y value you're getting is at 0, and that's an open circle. So it's a parenthesis, we're not including it. And then up from up above, every y value is covered, so it's 0 to infinity. Okay. All right, so on the back, for number 7, your domain, if you're coming along, there's definitely an x value for every negative x because of the green. And then you get to this open circle, but the x value is covered there. The x value is covered here, so your domain is negative infinity to infinity. So looking from left to right, there is literally a graph at every single point. Now, for your range, if you go from bottom to top, these graphs don't start until you hit the y value of negative 7. That's going to be a bracket. And then that graph, we have a y value, we have a y value, we have a y value. They're all covered. And because this green one will go up towards forever, your range will go to infinity. Okay. All right. Domain on the next one. Again, we're going forever left. This is just going to get wider and wider and wider and wider as you go up. So your domain is negative infinity to infinity. And your range, so your domain is negative infinity to infinity. And your range, okay, so here your range, your graph doesn't start until a y value of negative 3, because that's the minimum value of your parabola. So since it's a point, we're going to include it. And then this, thinking vertical, because it's range, y values, goes on forever. So it's to infinity. Okay. Your domain on 9 and 10, and if you obviously want to hit pause on the video and see if you can do 9 and 10 on your own and then check your work, please do so now. But your range is, okay, I'm sorry, your domain, let's start there. So your domain, because this is a square root graph, remember there we just had this little piece of this function. So there is no x value until 0, and that's a point, so we're going to include it. And then your x values go until you hit this open circle, and then it picks up with the closed circle. So 4 is accounted for, so it'll be 0 to infinity because our pink line goes on forever. And then your range, okay, same thing. There's nothing going on down here at all. So the smallest y value you have is 0. And then it does go on forever because this pink line would get bigger and bigger and bigger and bigger. So your domain and range are both going to be 0 to infinity with a bracket. And then for number 10, okay, so my domain, all right, so same idea because we have that square root. So we're not picking up x values. There's nothing going on here until an x value of -5. So your domain starts at -5, and then it continues on. At this point, we jump to the other function, and it's going to continue on forever because that absolute value goes forever. So it's -5 to infinity. And then your range, okay, well here our minimum value on our absolute value graph is at a y of -8. So the smallest value we're going to have is -8. And then here there is a gap, but it's covered over here. This will go on forever. So it's -8 to infinity. Okay. So today all we're going to do is just practice 6 more of these. So if you go back to the sheet that had your warm-up on it, I'm just going to walk through 6 more of these graphs and make sure, or maybe 5 more, I'm forgetting, but whatever. And we're just going to make sure we're going to do the whole thing. So we're going to graph them just like we did on Friday, but then we're going to add the domain and range in. And if at any point you want to test yourself and see how you're doing on it, just hit pause and then listen and see if you'll get your answer right. Okay, so for number 2, our breaking point is at 0. So I'm going to draw in my breaking point. Okay. Now my included value is down here. This is going to be my closed circle. So here, when x is 0, y is going to be 0. So that's going to be my closed circle at 0, 0. And then this says if x is less than or equal to 0. So we're looking for any x that is less than 0. So that might be something like -2. That might be something like -5. Just any x value less than 0. So if x is -2, then you should get a value of 8 for your y. And if x is -5, then you should get a value of 20 for your x, or if x is 5, excuse me, y is 20. So that probably won't fit on the graph, but at least we have this -2, 8 to go off of. Okay. And then it's everything less than, so we are staying on the left side of our breaking point. Okay. Now, your other one has an open circle at 0, but you still start there. So if x is 0, this is our cubed root function. So again, you probably need to put this into your y equals and look at your table. But when x is 0, y is 0, and that's going to be an open circle. So I just draw that open circle around the closed circle because they share it. Now we're looking for x values that are bigger than 1. So if you look in your table, if you're using your xy table from your graph, then you want to pay attention to the values that are nice, right? Try and avoid decimals. So if x is 1, then y is 1. And if x is 8, then y is 2. Now, pay attention to what your parent function looks like. I made my points kind of big. But you're going to have the end of your snake just half of it. Okay, so that's what your graph should look like. Now, as for your domain and range, your domain, the blue graph that is on the left side of your breaking point, is going to continue forever. So there is an x that is going to be taken care of. It'll just be extremely high. Okay, and then on the right side of your graph, there is always going to be an x value taken care of. So your domain here is -infinity to infinity. Now your range, well, you don't have any y values on this graph until you hit 0, and that's an open and a closed point. Well, because it's closed, it's 0, and then they go to infinity because it will continue to get bigger for your y's. Okay. All right, for number 3, our breaking point, again, is at 0. So I'm going to go ahead and draw that in. Okay. And with your breaking point being at 0, we are going to start with the first function, because that's what has our closed circle at 0. So at 0, when x is 0, you can use your table for this off of your graph. When x is 0, y is 3. Okay, and we want any x value that is less than 0. So -1, -2, etc., etc. Now remember, this is an absolute value graph, so you're looking at something like this. Okay, so you don't necessarily want to come up with a straight line. So you need to check and see, well, where's my critical point at? In this case, if you look, -1, you're at 2. And at -2 on your table, you're at 1. At -3, you're at 0. At -4, you're at -1. And then at -5, you're back up to 0. So you don't want to miss the whole v part of the absolute value function. So at 0, we're at 3. -1, we're at 2. -2, we're at 1. 3, we're at 0. And 4, we're at -1. Well, that makes sense, because thinking back to your transformations, this has moved left 4 and down 1. Well, your critical point's left 4, down 1, and then all of a sudden you start up again. So your graph looks like that. Okay. Now, going to the second function, which will have an open circle at 0, that's the square root function. So again, if you need to, go ahead and put that into your calculator and look at your table. So when x is 0, y is -1. Okay, and then I am not going to pull another x value until x is 3, because when x is 1 and x is 2, if you're using your table, they're decimals. So at 3, we're at -2. And I chose 3, I'm sorry, because x is greater than 0, so we're looking for values greater than 3. And when x is 8, y is -3. Okay, so at 0, we're at -1. That's an open circle. At 3, we're at -2. And at 8, we're at -3. And that's your square root function. Okay, so for our domain, well, moving left to right, every single x value is accounted for, because not only they are accounted for from -10 to 10, meaning at every x there is a point, some y, but they go on forever to the left on the pink function and forever to the right on the green function. So your domain is -infinity to infinity. Now, your range. Okay, so pay attention to this, because a lot of people see this and think, oh, well, my range doesn't start until -3. But really, if we were to keep going, if you were to look at that table, the next point you would graph is 15, -4. It's just going to be out here. And then the next point you would graph, even though it's going to take a while, it's going to be 24, -5. Those are going to keep getting big, more negative and more negative and more negative. So your range here really does start at -infinity. It's just hard to see because it happens so slowly. But remember, this is decreasing all the time because it's because it's a square root graph. So if it's decreasing all the time and going on forever, it will eventually hit every negative number and on the y-axis. Now, here, the graph looks like it stops at 3, but if you look at the other side of your absolute value, it goes on forever. So your range is going to be -infinity to infinity. So really pay attention to what the parent graph is, what you know about the parent function, and where those arrows are going. Okay. So on the back, we have 4, 5, and 6. Okay. So on number 4, now here we have a breaking point at 3. So I'm going to draw that in. Now we technically do have a breaking point at -2. But if you look, we don't have anything going on the other side of -2, because this is the starting point and this is the ending point. So we're going to have to pay attention to that when we do our domain and range. So let's start with both of these being closed circles. Okay, I'm going to go from -2 to 3, and I'm going to leave some room because if you look, that's a quadratic. So I want to make sure I have enough information to really get a good parabola out of there. So if you need to use your graph on your table, please type it in and do so. Okay, but when x is -2, you should get a value of 0. Okay, and when x is 3, you should get a value of -5. So those are both closed circles because of the equal to, so they're both closed. Okay, so at -2, we're at 0. And at 3, we're at -5. Okay, sorry, my points are kind of big tonight. Now let's see what's going on because we know that's not a straight line. It's a parabola. Look at its parent function. So at -1, we're at 3. And at 0, I'm at 4. And then I'm just going to move because I ran out of room. But at 1, I'm at 3. And at 2, I'm at 0. So at -1, I'm at 3. At 0, I'm at 4. 3, I am at, I'm sorry, 0, I'm at 4. I already graphed that 3, -5. Sorry, I'm confusing myself. That's why it's probably good to leave more space. Let's see, 1, I'm at 3. And 2, I'm at 0. So you're seeing just the middle part of that parabola there. Okay. Now, for the other one, when x is greater than 3, well, if you look, no matter what, your y value is going to be -5. Here, it's going to be an open circle because we're not including it. So at -3, I'm at -5, so I'm just going to put an open circle around there. Well, this is x is greater than 3, so any value greater than 3. So let's say 6, let's say 9, let's say 10. It doesn't matter what you pick. Your y is going to be -5. So no matter what you pick, it's going to be -5. So that is a straight line, the horizontal straight line. Now, if you notice, we don't have anything going on this side of the graph, and that's okay because it didn't give us a function that is in that part of the graph. So when we go to do our domain and range, your x's don't start until that first breaking point of -2, and then they do go on forever because there is an x, there is a point for every x, there is a y. So 2 to infinity is your domain. Now your range. Okay, so there's nothing going on down here. The first y value that you have anything happening at is -5, and that's going to be included because it's points. Okay. And then the highest y value we have, we're not going to infinity here, right? Because we only are going as high as that max point on the parabola, which is a y value of 4. Now that's a point, so you're going to have both brackets. So here you really got to pay attention to, you're not always going to have infinities. You have to really pay attention to what your graphs look like, what's the highest point, what's the lowest point, and go from there. Okay. All right, for number 5, we have a couple breaking points again. We have a breaking point at 1. And we have a breaking point at 4. Now they do give us 3 functions, so we should have something going on the left side, in the middle, and on the right side. So let's start at the top. Here, this is going to be a closed circle. So when x is 1, again, if you need to use your calculator, okay, you can do the cubed root. Remember, you find that in math, and it's option number 4. The cubed root of x minus 6, and use your table. So when x is 1, y is -5. Now remember, this is your snake graph. We're looking for any value that is smaller than that, any x value smaller than that. So 0, -1, -2, -3. Okay, so if we look at 0, we're at -6. At -1, we're at -7. And then -2 and -3, those are going to get you decimal yucky answers. So I'm actually not going to use those. And I am going to use the next answer that is going to be easier to graph, which is at -8, -8. So we are at 1, -5. That's a closed circle. We're at 0, -6. We're at -1, -7. And then -8 all the way out here, -8. So you're seeing just part of the snake. Okay. Now, if we move on to our middle graph, we have 2 open circles because we're not including the 1 or the 4, but we still want to graph them. Okay. So, when x is 1, we get a y value of -5. And when x is 4, we get a y value of -4. Now, pay attention to the fact that this is the 2 points in between there, the 2 and the 3 are ugly, but we want to make sure we do this graph justice because we are at 1, -5 with an open circle. And then we are at 4, -4 with an open circle. But you don't want to draw a straight line because that does have some curvature to it because it is part of your square root graph. So you don't want to draw a straight line. It does have some curvature to it. Now our last one is going to be a closed circle. All right, so we're starting at 4. Okay, and when x is 4, I'm just going to substitute the value in, but you can use your table if you need to. -2 times 4 is -8, plus 3 is -5. So at 4, we're at -5, and that's a closed circle. So you can see the importance of being really precise here, because if you're sloppy in your graph, this is not going to look like you know what you're doing, and that'll mean points off. Now, we're looking for any x values that are bigger than 4. So that's 5, that's 6, that's 10. It's whatever you want it to be. Okay, so just go ahead and figure out what those values are. And when x is 5, you should have a y value of -7. And when x is 6, you should have a y value of -9. So at 4, we're at -5. At 5, we're at -7. And at 6, we're at -9. And that's going to go on forever. Okay. So for your domain and range here, your domain, for every x value, if you're thinking left to right, there is a point on the graph at every x value. So your domain is -infinity to infinity. But your range here, because of the orange graph, that last -2x plus 3 line, it is going to go all the way down. So you are going to start at -infinity. And because of your cubed root, same reason, this would go all the way down. It would just take a really long time. But the highest y value you're going to see here is on the green at a y value of -4. And that's going to be a parenthesis because that's an open circle, so it's not included. Okay. And the last one. Okay, so here we have our breaking point at -2. Okay, so now that you have your breaking point set up, we are going to start with our included value first. So at -2, you have the cubed root of x plus 1, and make sure you put that in your calculator correctly. Okay, so when x is -2, we're at -1, and that's going to be a closed circle. And then we need all x values that are smaller than that. So an x value that's smaller than -2, but still giving me a good idea of what that graph looks like, doesn't happen again until -9, -2. So at -9, we're at -2. Now, do not draw a straight line here because this is a cubed root graph. So this is going to have some curvature to it. Now, your critical point is happening here, but it's happening on the other side of your breaking point. So the snake would be coming down kind of like this, if you can follow my little mouse here, and then hitting this point and curving that way. So don't just draw a straight line. Try and give it some curvature if you can. Okay, and now this other one, we have the absolute value of x minus 5. Okay, this is going to be our open circle. This was our closed circle. Okay, so if you're looking at the negative absolute value of x and then minus 5, we are going to start at negative 2. Okay, and when x is negative 2, you're at negative 7, and that's going to be an open circle. So at negative 2, negative 7, we have an open circle. And then we want x is greater than that. So anything bigger, now remember, we're still looking for that v. So we're going to go negative 1, 0, 1, 2, and see if we're starting to see our v in there and finding our vertex. So when x is negative 1, we're at negative 6. When x is 0, we're at negative 5. When x is 1, we're at negative 6. And when x is 2, we're at negative 7. So we have repeating values for our y, so I'm guessing we hit our vertex because we have some symmetry there. So we're at negative 1, negative 6, 0, negative 5, 1, negative 6, and 2, negative 7. And you can tell by plotting your points you did hit that vertex point and you have a good graph. So last but not least, your domain and your range for this. Well, if your domain, you do have an x value accounted for in every single spot. So your domain is negative infinity to infinity. However, your range, here, this is a cube root function. So it looks like there's a gap between my red and my purple, but really that's going to keep going forever and ever and ever and ever. So we are starting at negative infinity. But the highest y value that you're going to get to here is at negative 1. There's nothing going on after that y value of negative 1, and put a bracket there because it's a point. Okay. So the actual graphing is nothing new, unless you weren't here on Friday, then it's totally new, and you're going to have to practice it. But adding that domain and range in, what are the possible x values, what are the possible y values, that is what you're going to focus on tonight on the homework as well. Now, there is a typo on number 6. So when you go to get your homework, you can just hit pause on the video so you can still see this on your screen. But on number 6, if you could change, we just forgot to put the included. Neither of the negative 3's were included. So please make sure on number 6 you add that equals to with x is less than or equal to negative 3. Okay?